Let's move on to the next question. The next question says, as part of the quality control, a pharmaceutical company tests a sample of manufacturer pills to see the amount of active drug they contain is consistent with the labeled amount. That is, they're interested in testing the following hypotheses. You have been given the null hypothesis, you have been given the alternative hypotheses, you have been given the population standard deviation, you have been given the number of samples or the number of pills in the sample, and you have been given the significance level. Alpha is 0.05. You have been also given the sample mean. You need to calculate the test statistic or the Z statistic. This question is very straightforward. Let me go ahead and remove the calculation from the previous question. You have your null hypothesis as mu is equal to 100. You have alternate hypotheses. Mu is not equal to 100. X bar is 104. Population standard deviation is 5. You have been also given the number of samples, which is nothing but equal to 10. Oh, you need to calculate the Z statistic, which is X bar minus mu upon sigma by root n. This is going to be my value of Z statistic. So it's just value substitution. Now this mu right here is the initial condition that we have set in the null hypothesis. In this case, mu will be equal to 100. So it will be 104, your sample mean, minus 100 divided by, I've been given my sigma as 5. And my sample size is 10. So let's do the calculation. This comes out to be 2.52822. You just round that off to the sec second decimal place. You will get it as 2.530. So your answer to this question should be all right. Let's see what the actual answer to this question is. It is indeed 2.53. Let's move on to the next question. If you read the next question, it's exactly the same as the previous one. The details are the same. The sample mean, sample standard deviation, number of samples, sample mean, null hypothesis, alternate hypothesis, everything is the same. Here you need to calculate the p-value associated with this test. So you've already calculated your Z statistic, which is 2.53. You now need to go ahead and calculate your p-value. Now, p-value for this test will be what? This test, as you can see, we need to find evidence for population mean not equal to 100, which means we are interested in calculating the probability of both sides of the aisle. greater than as well as less than. So it is a double-sided Z test. For a double-sided Z test, my p-value, as we saw, is twice into p of, sorry, let me rewrite this. Z greater than equal to mod Z. This right here is going to be my resulting p-value. How do we calculate this? We need to calculate Z greater than or equal to mod of Z, which means we need to calculate the area towards the right. And so we will be using, for that we'll be using our function p norm. My Z statistic was 2 point, my result is coming out to be 0.0114. Let's see what's the actual answer. Indeed, it is 0.0114. Pretty straightforward question, nothing very complex. We have already seen a plethora of questions based on this concept. This was pretty straightforward. The next question, it is giving the one sample t test. The one sample t statistic for testing h naught mu is equal to 10 and h1 mu is not equal to 10. This is my null and alternative hypothesis. For a sample of size n is equal to 20 and the confidence level as 0.05, should reject h naught if the absolute value of t is greater than or equal to which of the following values. So we need to find the value post which we can reject our null hypothesis. So we need to find the critical t value in this case. The idea is this is t critical, and if your point lies beyond t critical, which is somewhere here, you can reject the null hypothesis. All right. Your n is equal to 20, it's less than 30, which means it's a t test, and the confidence level is 95%. So to calculate the critical value, what function do we use in R? You have been given your confidence level as 0.05, that is your alpha level. You know, this is a one-sided t-test. So the area to the left of the critical value, which is this area, this right here, this is 0.95. And so I have been given the area to the left, and I want to calculate the critical value. The function that I'll use is qt. Just like qnorm, we'll use qt. Degree of freedom is going to be n minus 1 for t-test. So 20 minus 1 is 19. 1.73. Oh no, I did something incorrect over here. So your 95% confidence interval lies to the left. Oh no, I did a mistake over here. This is not a one-sided t-test. This is a one-sample t-test. But if you look at the alternate hypothesis over here, it's double-sided. So your alternate hypothesis mu is not equal to 10, which means that I'm so sorry, all of this is wrong. It's two-sided. And this right here is going to be my critical value TCL. This right in the middle, this is going to be my 95%. And these two areas will be equal. And this is, and since both, because of the symmetric property, these two areas are equal. This is 0.05. So to the left of critical value, the area is not 0.95, it's 0.975. Had this test would have been a one-sided t-test, our first answer that we just calculated, that would have been correct. But this is not a one-sided t-test. It's a one-sample, two-sided t-test. So apologies. Now we are getting the right answer, 2.093. So this is how you will calculate this. I know I made a mistake. It happens often, but the important thing is we understand where we committed our mistakes and never repeat them again. So the next question is to find the critical value associated with the probability of 0.90 to its left and with 5 degree of freedom. So probability to the left. This is interesting. I have been given the probability to the left of the critical value as this is the probability to the left. This is given as 0.9 and my degree of freedom is equal to 5. So with this, let's calculate the answer. If this is what is given in the question, the way you will calculate your answer will be, you've been given area to the left is 0.9 and you've been given the degree of freedom as 5. So our answer will be 1.475. 1.475884. So technically, if you round it up, you'll get 1.476. So this is exactly what we are getting. Pretty easy question, pretty straightforward. Let's move on to our next question. A sample of 16 observations were taken from a population of interest. Conduct a test of the following hypotheses at alpha level 0.025 level of significance. So this time my confidence interval is 97.5 or 0.975. The sample mean was calculated as 83, sample standard deviation 10. What is the test statistic for this particular test? Now, test statistic calculation, we have seen before, it's pretty straightforward, nothing very complicated. How do you calculate a test statistic? You calculate a test statistic using the equation x bar minus mu upon s by root n. Now you have been given your sample mean as 83. Initial condition for null hypothesis 90. Sample standard deviation has been given as 10, and this is you divide this by root of 16. Let's do a quick calculation. 10 divided by square root of 16. You get minus 2.8, and that is the answer, minus 2.80. So this wraps up our sessions on problems on the concepts that we have discussed on normal distribution, standard normal distribution, confidence interval, z-test, t-test, and all the concepts that we have discussed up until now. So from the next session, we'll be starting off a fresh topic, and some of the concepts that we have discussed in the previous sessions will be extremely handy as we move forward. So if you have any questions or any uncertainties or doubts in any of the concepts that we have discussed up until now, I will request all of you all to watch the previous sessions and get your concepts cleared before we move on to our next session. We'll be starting off the next session in our next lecture. So I'll see all of you all there. Thank you so much for watching, and I'll see all of you all in the next video. Thank you.